In this video, we're going to be looking at rational and irrational numbers. We're also going to look at decimal and fraction conversions, as well as adding and subtracting fractions. So remember, rational number is going to be any number that can be written as a ratio. So for an example, whole numbers work, right? 3, -4, 1/2, -3/4. Right? We could also write rational numbers as decimals, but these decimals have to be terminating, right? They have to have an end, or they can be repeating. They have to have some type of pattern. So you could have 0.75, -2.15. These both have an end. And then decimals that are repeating or have a pattern could be 3/10 repeating or 0.3 repeating. We could also have -2.86 repeating. All right. So you have decimals that are that are terminating. You have decimals that are repeating. All right. If you are looking at irrational numbers, remember these are just the complete opposite. So these are numbers that can't be represented as a ratio. So numbers that come to mind are the square root of 2, the square root of 3, pi, and e. Okay. They could also be written as decimals that are non-terminating, right? Decimals that never end, they go on infinitely, or decimals that don't have a pattern. So if I'm looking at decimals that are going infinitely, I could say 3, 5, 5, 1, 2, ... Same as any decimal that doesn't have a pattern. I could say 2.77104.5 ... Okay, the reason why we're allowed to do square roots and these numerical symbols as well is if you were to take the square root of 2 or square root of 3, these are numbers that turn into decimals that are never ending. Same with pi and same with e. So you can either use a calculator app or Google Calculator and determine what these exact values are to see that they are irrational. If we move on to, let's see, decimal conversions. If you want to convert a decimal to a fraction, okay, let me just change the color. If you want to convert any decimal to a fraction, you want to say the decimal out loud. Now, you want to pronounce it in a mathematically correct format, right? So this is not 0.75, this is 75 hundredths. Once you get to this point, you want to ask yourself, can you reduce your fraction? In this instance, you can. You could divide top and bottom by 25, and you will get 3/4, or 3/4. You can't reduce this any further. If you look at a whole value, right, so 1.2, this is going to be 1 2/10. This is going to be a mixed number. Oops. Okay, you can reduce the 2/10. You can't reduce the whole number, but you can reduce the 2/10. They both share a common factor of 2. So you'll be left with 1 1/5. If you are converting fractions to decimals, okay, you can simply do the operation that's happening, right? So a fraction is really taking the place of a division sign. So 1/2 is the same as saying 1 divided by 2. Now, if I'm setting up my division problem, the first number is going inside my division sign. The second number is coming on the outside. Okay, so I'm going to ask myself how many times does 2 go into 1 without going over? It doesn't. So I need to place a decimal here that doesn't change the value of 1. So 1 is the same as $1. Right? 1 is the same as 1.000. You could place as many zeros as you need. Once you place a decimal, you want to line it up. Then ask yourself how many times does 2 go into 10? It goes in 5 times with no remainder. So you don't even need this final 0. Your final answer is going to be 0.5 or 5/10. All right, now let's look at a mixed number. So you have 2 2/3. Two ways I can look at this. You can either convert it to an improper fraction and divide top and bottom, or you could separate these in halves, okay? You have 2 as a whole number. You don't have to convert anything, but you have 2/3 here. So you can just simply divide 2/3, 2 by 3, right? Remember, first number goes on the inside, second number goes on the outside. How many times does 3 go into 2 without going over? It doesn't. So I'm going to apply my decimal here. How many times does 3 go into 20 without going over? 6 times. Remainder is 2. This is going to keep going on and on, so I'm just going to add my 0 here. 6 again. I could stop here because I know it's just going to continue on forever. So instead of writing 0.666666, I'm just simply going to put a bar over the number that is repeating. So this is essentially 0.6 repeating. Now, I still have that whole number here, so I'm going to add that to the whole number. It's going to be 2.6 repeating. If you convert it to an improper fraction, you will get a fraction of 3 times 2 is 6, 6 plus 2 is 8, 8/3. In which case you'll get 2.66666 repeating, which is the exact same answer. Now, moving on to adding and subtracting fractions. If you are adding and subtracting fractions, one big piece of advice you have to follow is you have to have the same denominators. So if I have 1/6 plus 3/4, I want to make sure they have the same denominator. In order to find the lowest denominator possible, I want to find the lowest common denominator or the least common multiple. So in order to achieve this, I could list out my multiples of the denominator. So multiples of 6 are going to be 6, 12, 18, 24, so on and so forth, right? You could stop at 30. 1, 2, 3. Multiples of 4 are going to be 4, 8, 12, 16, 20. Probably stop there. Now you want to find the lowest number that they both share. In this case, I'm going to change colors. The number they both share is going to be 12, right? And that's the lowest number that they both share. Okay? So let's convert this. I want to convert these both to have a denominator of 12. How many times does 4 go into 12? Okay, it's 3 times, right? So 4 times 3 is going to be our rule. So you want to multiply top and bottom by 3, giving you 9/12 on the right. Just going to circle this. And on the left-hand side, you want to multiply top and bottom by 2, and you'll get 2/12 on the left-hand side. So the reason why I'm circling these is so that you can bring those values down. So now I'm going to go back to that orange color. I have 2/12 plus 9/12, and I'll get 11/12 as my final answer. Now I can't simplify this any further. If I could simplify it any further, that would be my final step. All right, so let's move on to mixed numbers. Adding and subtracting mixed numbers is a little bit trickier than just regular fractions. So when I am adding or subtracting mixed numbers, there's a couple of things that you can follow. You can simply convert the mixed numbers to an improper fraction, and you can add them across if they have the same denominator. Another way you can look at this is if you stack the fractions. So what do I mean by stacking? If I have 5 1/5, I'm going to write this vertically. Plus 6 1/3. Okay. Now these are stacked because they're stacked on top. I'm going to look at my whole numbers. I have 5 plus 6, that's going to give me 11. Now if I look at my fractions, they don't have the same denominator. So I want to convert these to fractions that have the same denominator. So let me just pick a different color here. 5 and 3, if you want to list your multiples, will give you a denominator, lowest common multiple of 15. So you want to multiply your top and bottom by 5. You will get 5/15. Here, you will get, if you multiply top and bottom by 3, you'll get 3/15. So now, I can add the blue fractions. 3/15 plus 5/15 is going to give me 8/15. So as a final answer, I'm going to have 11 and 8/15. If you can simplify this, you still have to simplify it. All right, that's still your final step. In this case, I can't divide 8 and 15. They don't share a common factor. Now, subtraction's a little bit tougher. So let's see if I can. There we go. If I'm looking at 4 and 1/8 minus 2 and 1/4, again, I'm going to stack these. 4 and 1/8 minus 2 and 1/4. 4 minus 2 is going to be 2. The problem I run into here is 1/8 minus 1/4. 1/8 is much smaller than 1/4. So I'm going to run into some difficulties here. If I convert these both to have the same denominator, I'm going to have 24. So this fraction is going to be 3/24, and this fraction is going to be 6/24. So I can't subtract those because I can't subtract the lower fraction from a larger fraction. I'm going to have to do some type of borrowing. So before I write this 2, I'm going to backtrack. Okay, if I know that this 1/8 is a smaller value, okay, I know that I'm going to have to borrow from this value. So let me just convert both these to have the same denominator. So again, I said 24. This is going to be 6/24. So I multiply top and bottom by 6. And this is going to be 3/24. Okay. Actually, let me backtrack. The least common multiple is going to be 8. Right? Let's make this a little bit easier for ourselves. Okay. So I'm going to convert this to 2/8. It's a little bit easier to do. All right. Now, if I'm borrowing here, I have 1/8 minus 2/8. If I'm borrowing here, I'm going to cross out this 4. And I'm going to make it a 3. Now, in order for me to do so, I can't just turn a 4 into 3, okay? In order for me to do so, I'm losing that whole value. So what fraction will give me a whole number of 1? It's going to be 8/8. So I can turn this 4 into a 3 because 3 plus 8/8 is the same as saying 4, right? So I'm not really changing my value at all. It's the same value. So now I'm making this 4 and 1/8. I'm crossing it out. I'm making it a 3. And I didn't lose, well, I lost the 8/8. So I'm going to leave this 8/8, right? So in reality, my problem becomes not 4 and 1/8. I can make it 3 and 9/8. So I'm going to cross this out again. All right, this is going to be 9/8 because I borrowed. This 2 and 1/8 is still going to stay 2/8. So I'm going to leave this. So now I have 3 minus 2, which is 1, and I have 9/8 minus 2/8, which is 7/8. This is only when you need to borrow, and my final answer is going to be 1 and 7/8. Okay. Now, another scenario you're going to run into is a problem like this. -7 2/3 minus 1 4/5. Now, if you stack these, again, you can convert these both to improper fractions and maybe a little bit easier. If you're converting them to improper fractions, just remember you apply the minus sign at the end. So after you get your improper fraction, apply the minus sign to your numerator. If I'm stacking these, remember I have to follow my rules here. So -7 minus -1 is going to give me, if I do keep, change, keep the -7, change the -2 addition, and change this positive to negative. So I'm going to have a -8 on the left-hand side. Now, when you're dealing with negative signs and with mixed numbers, the negative sign really goes, it's kind of like a distribution, a distributive problem. The negative sign goes to the whole number and the fraction. Okay, so I really have on the right-hand side, let's see, negative 2/3, right? And I have a minus 4/5. Okay. All right, so now we got to convert these to have the same denominator. Whoops. They're going to have the same denominator of 15. So 3 times 5 is going to give me 15. So the rule is going to be multiply top and bottom by 5. I'm going to have a negative 10. Okay. And here I'm going to be left with negative 12. Okay. So if I subtract these, right, keep change says to keep the first value, negative 10. And I'm going to, remember, change the subtraction to addition, and then change the final value to negative. So I'll have a negative 22 15ths. Okay? So okay. Now, if I have that negative 22 and 15ths, okay, if I have negative 22 15ths, my numerator is much larger than my denominator. Okay, so that becomes, right, negative 1 and 7/15. I still have this negative 8 here, and I have a negative 1 and 7/15. For a final answer, I'm going to have negative 9 and 7/15. And I can't simplify this any further. This is probably going to be the hardest problem you run into. If you have any issues with that, you can either, again, change this to an improper fraction. It's probably your best bet. Just remember you're applying the negative sign after you've turned it into an improper fraction.